All right. Welcome, everyone, to the AI in Japan session of the European AI Week 2022. So this is a very special session because the other sessions, I think, are all, or most of them are located in Belgium or Europe. And this one is streaming all the way from Tokyo. We have the pleasure today to welcome a few prominent speakers in the room. So there is Michael Spranger, Mizuki Oka, and Antoine Pasquali, which I will introduce in a second. But I'd like to give you a taste of the general topic. All right. So first, I introduce myself. I'm Ola Witkowski from Cross Labs in Kyoto, Japan. And we have an institute here studying the fundamental principles of intelligence, artificial as well as natural. And yeah, we try to bridge between academia in the industry. And really it's fundamental research at its core, but also we try to really relate to problems that people have in practice right now. And there are very specific needs that Japan has that the rest of the world has in a very different way. So I'll come to that in a second. Yeah, we have a few projects that we focus on. Collective intelligence is one of the core things I do in my research, but also open-endedness, how to teach machines to keep creating forever, but also how to understand better cognition in humans, and then how to extend that over to the world of machines. We try to solve those problems that are very important in Japan. One is with the aging population, we'll have a different workforce type of challenge that I think will not be encountered anywhere else in the world before we do here. Japan is investing a lot in innovation, I think, compared to other places in AI right now, and did it in very different ways than the rest of the world. Okay, so this is me. And the question that I will ask here to everyone, and starting with the speakers, is what is unique about AI in Japan? So what is so special? And maybe certain things are universal, and we certainly think that we practice the same language of, whatever it is that you use, but ConvNet, Python, all of that is sort of universal. At the same time, there is something special in Japan. I see that Nathanael joined us, and I want to thank him again to have allowed me to organize this nice session here. Nathanael, would you like to say a word before we start?
Okay, thank you so much, Olaf. I think I'm a bit too late. Have you already introduced all the panelists?
Yes, not yet. You're first to speak.
Okay, so thank you very much, Olaf, for having organized this session that is expected by many. Because on the last day of your European AI Week, that is counted 99 events, we really broaden the scope and go until Japan, China, we go to Canada, and it's really important. We have already had some teasing on the multicultural approach we can have on AI. You were organizing that also. But yeah, I just want to thank you, and maybe you can introduce the outstanding panel you have composed. I would say that we were in contact last year because we did organize the Belgian AI Week. So this year it's the first attempt for a European AI Week, and I think we succeed. From day to day, there are many more people coming and participating. So thank you so much, Olaf, for giving your payback to the country you've learned in. I'll let you the floor. So one thing, at 6 p.m. Brussels time, so maybe it's a bit late for you, we will have the closing ceremony, and today is the third birthday of AI for Belgium, so we will have some celebration. Okay, thank you. We are impatient to hear from you.
Thank you so much, Nathanael. And yeah, this has been a very fun week. I invite everyone to check out, if you're just checking out this one, there are many other sessions in the same kind of list on YouTube that you can find. I invite you to check that out as well. All right, so AI in Japan, a very big topic. Before I introduce everyone, I think I should do that right before they speak. Let me introduce the topic as I see it in just a couple of minutes. So I think there is very creative research, and the first thing that comes to mind is robotics in Japan. Very impressive things that everywhere in the world, I think people have seen, and some are very intense about that. Visit Japan just to see all of those robots. This is the Alter robot developed by Ikeyami Lab and Ishiguro Lab. Just a few years ago, and now they have several of those that are interacting, very lifelike and also very uncanny. So as you know, this is a concept discovered or invented by Masahiro Mori. Capturing how certain machines, as they approach the aspect, the looks of humans, become very strange and uncanny to interact with. And we brought that in Japan to a level, the next level, I guess. And some of those are very interesting. It's not only about this uncanniness, discovering the uncanniness, but it's also about bridging over it and really feeling empathy with artificial intelligence, artificial life even. And this is the example of the Sony Ai, of course. And when basically the support to those small robot dogs was discontinued for a little while, people felt more attached, very interestingly, to those machines, because they were able to, die again, a little bit like living creatures, and that made people certainly more attached. And this attachment was very strong here. There's a lot of press around that. And I think that people feel more than in other continents, other countries. And maybe it comes from Shinto, Buddhist, a mix of different cultures here, where it makes sense that the artificial creature would have a life, a soul of its own. And we really respect the relationship with the machine. So we really live with the machine, I think, and it extends to more than robotics. Of course, robotics is the very graphic thing to show, but I think it happens as well with all sorts of artificial intelligences, including just algorithms. And of course, it's because they take more space in our lives. I think that's everywhere in the world, but in particular, maybe because of the aging society, we have something of a big maybe effort more than anywhere else that is being given to living with AI and having them perform healthcare, but also serving us in different ways. It's not perfect. Sometimes we had to borrow robots elsewhere, maybe for cases like Fukushima or something very specific. But robotics is, and AI in general, is a very big area of focus here for research. Also creation. This is an example of Osamu Tezuka, of course, very famous mangaka who created a very famous, maybe if you read a little bit of those comics that came from Japan. This one has been created after his death. Just a couple of years ago, there was a controversy about this AI that created a new comic by himself. And I guess this is in other places, those kind of projects have been stopped. Here, it was very encouraged and people were very supportive towards this idea of having an AI continue the work of someone who was no longer present. So I think there is a real different, I guess, relation to AI, less fear, maybe. Maybe less of this kind of apocalyptic scenarios that you see in cheap movies nowadays, and perhaps there is some displays a sort of difference in mindset that we have here. And for what concerns everyone in the virtual room here, I think in research, in particular in strategy governance, there is a lot that is being done in Japan. Maybe I'll cover a little bit of that. These are just a few familiar faces on pictures, some conferences, some major events. But first, I think I want to give a bit of time for others to introduce themselves, maybe their projects and their point of view about what is AI doing in Japan. So today we have Michael Spranger from Sony Ai. He's the CEO there, also researcher at the Sony CSL Computer Science Labs, doing a lot in AI right now. Mizuki Oka, welcome as well. From the University of Tsukuba, where she's just finished a book. Maybe she'll say something about it, about artificial life systems. And we created, Mizuki, you are the leader of this new society for artificial life in Japan, just created last year. And finally, Antoine Pasqualivo, and this first phase. Before we go into discussion, Antoine Pasquali, of course, CTO of Cross Campus AI company, specialized in manufacturing here in Tokyo, doing a lot of amazing projects as well. All right, shall we start with Mika? Mika, would you like to feel free to just share your slides if you want to?
Sure, thanks so much. Thanks, Olaf, and thanks for the invitation to talk today. And briefly introduce myself and talk a little bit about the work we do at Sony. My name is Michael Spranger. As Olaf mentioned, I'm the CEO of Sony Ai, but I'm also a researcher at another institute, which is part of Sony, called Sony Computer Science Laboratories, or CSL for short. These research institutes are very different, and maybe I can talk more about this later in the panel. And also, if you're interested, Sony CSL actually just finished an open house today, and the materials are still up, so you can find more on the webpage. For the purpose of this short intro, though, I'm going to focus exclusively on Sony AI for the obvious reason that the focus should be on AI here today, and Sony AI is laser focused on artificial intelligence. Our core mission is to unleash human imagination and creativity with AI. And for this, we are developing AI that empowers artists and creators to build next generation products and services. And we have a strong focus on the societal issues that AI can both help address, but also the issues that AI raises for society. And so as we are developing and deploying this technology. Sony AI is a new organization, relatively new organization. We established the company in 2020. We do have physical offices in Tokyo and in Zurich, but we also have a strong presence in the US and Canada, and where we are actually a remote organization. And partly due to COVID, we also have now employees working on all continents for Sony AI. We are really very, very remote organization, very distributed, dispersed organization at the moment. And so we have a truly global presence. We do 4 flagship projects. We are developing AI in the areas of gaming, imaging and sensing, and gastronomy, and of course, AI ethics. These areas are linked in many ways to Sony and Sony's activity. Our imaging and sensing project focuses on cutting-edge sensing technology, such as event-based sensing, and utilizes and contributes to the activity of Sony in the area of image sensing, including CMOS image sensing, but also RGBD. The gastronomy flagship projects focus on creative AI in the area of food. Specifically, we are interested in building creative systems that help create novel dishes, but also robots that are able to manipulate food in ways that humans can't. Obviously, Sony is doing a lot of work in gaming, hence we have a game AI flagship project that I will talk about a little bit more detail in a second. Last but not least, AI ethics is important for all aspects of AI, including research and development, but also deployment and AI model lifecycle management. And so we have a flagship project on that. So we are trying to do great research and development projects. And one of the key projects we recently were able to share as a big breakthrough for AI is our Game AI project, which was published in Nature and also featured on the cover. In that work, we did train AI agents to race in Gran Turismo, which is an ultra-realistic racing simulation. The video on the right shows agents racing against the top humans. And we have built reinforcement learning agents that were able to beat the top racers. We call these agents actually GT Sophie. So there are significant challenges that we solved in this particular breakthrough. Specifically, we addressed three things. We addressed the physical realism of the game. That makes it a really interesting AI breakthrough. You need to have superior race tactics. And there's also a concept called racing etiquette or sports etiquette that you need to be able to solve. And so we built reinforcement learning agents that are focusing on solving these very important issues. Specifically, Gran Turismo Sport is a driving simulator that attempts to capture the dynamics of racing. And so GT Sophie has to find the right lines that squeeze the last tenths of a second out of the track by really optimizing the control. But racing also means that you're not alone on the track. So Sophie has to find lines to pass opponents, taking into account the opponent's reaction, as well as complex aerodynamics interactions between the cars. And then last but not least, racing, you need to adhere to very imprecise rules and race etiquette. And so Sophie had to learn to drive, attack, and defend aggressively while keeping to the rules. And so we address these problems using reinforcement learning, especially deep reinforcement learning. Gran Turismo Sophie observes the environment, such as the car's speed and acceleration, relative position of course border and opponents, as well as the progress of the car along the track. And based on this, Gran Turismo Sophie learns to take actions, such as using the throttle, steering, or braking. And of course, as is custom in reinforcement learning, Sophie gets a positive signal, a reward when things are going well. And when things are not going well, then she gets a negative signal. So let me show a few examples of the racing of what Sophie learned. This video shows an agent actually being able to take a specific chicane in a great way. This is on a track called Seaside, and the car is a Mercedes AMG. The chicane is coming up right now, actually, it's going to come up right now, is called the Chicane of Death because, there are concrete walls left and right. And if you hit one of those walls, it's actually going to slow you down a lot. And I don't know if you catch that, but she's able to learn to take that corner in a really remarkable way that even surprised the humans that were watching this and the best drivers. Another thing that she's able to do is shown in this video, and this is around sports etiquette. She's able to, so this is Lago Maggiore, the bluish car is Sophie and the white car is a human. And we see a really fair racing battle here where Sophie is aggressive, but also kind of leaves enough space not as to kind of crash into the other car, which is really important in racing. Of course, in real racing, there's actual accidents, but even in simulated racing, this is not Demolition Derby, this is a real racing simulator. So it's important to be sportsmanlike in the interaction with the humans. And then last thing I wanted to mention here is, as I mentioned, these AI agents were able to beat the best humans. And this is very exciting for us. And that also helped us, of course, publish this in a top journal. And so it's very amazing to win these races. But even more important to us is how human drivers feel racing this technology. And so here are two testimonials. Miyazono-san on the left is one of the top GT drivers in the world. And he told us that he forgot that he was racing against an AI and that he wants to race more. And on the right here is Emily Jones, another top driver. She told us that she got a lot of inspiration from the racing techniques of GT Sophie. And for the project, this is really extremely important feedback, as our long-term goal is not just to push technology forward, but to bring this really to the players and the creators. All right, thanks for your attention. Feel free to check out the website. Thanks for the invitation to speak and looking forward to the panel.
Thank you, Mika. Amazing. Yeah, I think it's a very nice signature project for creativity and entertainment. Mizuki, would you like to follow?
Yes,
yeah.
So can I take over your screen?
I think I already
Thank
stopped,
you.
yeah, so it should be you.
Oh, okay, thank you. So, all right, so thank you for organizing this session, Olaf. Can you hear me?
Yeah.
Oh, okay, great.
Yeah, we can
so
hear you.
Today I'd like to talk about a research area called artificial life. That's an area that is much less known compared to AI, but I think it's an important field, and it's also a very active field in Japan. So what comes to your mind when you hear the term artificial life? Maybe it's a Frankenstein, or it is more like a genetically engineered organisms, such as synthetic biology. But in fact, artificial life is a field that seeks to understand life by creating lifelike artifacts from inorganic materials like computers, algorithms, robots, or chemical reactions, rather than living things such as DNA or cells. And one way to create life is, we believe, is to create open-ended evolution, which was also introduced by Olaf's slide. And this is because we believe that if we can create endless evolution, like natural evolution, life forms should also emerge. And I myself is interested in artificial life as a computer scientist. And it's because even in the field of computer science, it is an important issue to ensure that web services on internet or applications continue to be used, or to create new things continuously. And today I'd like to introduce a book on artificial life, which explains the field of artificial life in a very easy to understand way. And the book is called Artificial Life, with a subtitle of Towards a More Lifelike AI. And the book describes what kind of research has been done in the field of AI life, what algorithms and softwares have been created, and how they can be used. It also describes the attempts to meet the grand challenge, so that's the open-ended evolution. And the author is myself, and I was originally doing machine learning and data mining research on AI for tasks such as classification, predictions using data on the internet. Then 10 years ago, I came across this field of artificial life, and now I am studying and develop softwares related to SNS and other online communications, but not from AI perspectives, but more from AI life perspectives. That means how services continue to develop, or how interactions affect the collective phenomena on the internet, and so on. So in other words, I'm interested in open-endedness created on the web or on the internet. And the book introduces three main concepts for the open-ended evolution. And I'd like you to understand these three concepts and use them to help you with your own challenges, such as generating new ideas or plans, or developing services that can continue to be used. So the first concept is the embodiment. The presence of the body creates the, maybe let me stop the, So the presence of the body creates interaction with the environment, and the new movements would emerge. And the idea of intelligence created by the interactions between the body and the environment was brought to attention by a concept called Subsumption Architecture by AI researcher Rodney Brooks. And the main idea of the embodiment is that organisms' cognition is not in the brain, but rather embodied. And researchers like Rob Pfeiffer or Carl Sims were also inspired by this idea, and they created Swiss robots or virtual creatures that evolve. And those studies led to the soft robotics with more complex and lifelike movements by researchers like Odd Lipson and his colleagues. And I studied these systems like social network services, and the embodiment of these systems varies depending on the services. And the embodiment here refers to what media is used for communication, the way information is conveyed, and the way feedback is obtained. For example, text is mainly used in Twitter, whereas pictures is mainly used in Instagram. And also the way information is spread differs in these services. That also results in different ways of dealing with the information. And each service also has its own different network structure, so the environment is also different. And the idea of looking at social network services or applications from the perspective of emergent phenomena created by these interactions between embodiment and environment has given me a new perspectives on those services. And this idea has led to research into how, for example, the presence of others differs depending on the way information is presented in communication. And the second important feature of AI for open-ended evolution is the collective phenomena. And there are new phenomena that emerge when individuals interact in a group. And such collective phenomena is studied in AI models, such as game of life and the void model. And for example, the game of life can create overreaching patterns, such as movements, replication, and self-reference. And a famous void model reproduces the movement of flock of birds. And such collective phenomena can also be found on the internet. For example, the flow of data created by packet switching networks, which underpins the flow of data on the internet, is also an emergent phenomena. And as in the phenomenon buzz on social network sites is also an emergent phenomena. And by designing and experiment with the various interactions using real-life simulations, for example, based on agent-based models, it is possible to understand these various collective phenomena, or the spread of fake news, or the creation of echo chambers. And the third important characteristics from A-Life community to create open-endedness is the ecosystem. We human beings do not live alone, and we live in groups. And the same philosophy applies to other living organisms. And A-Life experiments simulate ecosystems have also proven that the creatures evolve forming an ecosystem. For example, interestingly, it has been shown that the group can only evolve by incorporating individuals such as parasite species, which at first glance offer no benefit to the group. And this is an idea that is linked to the collective intelligence of the internet. And the internet has shown us many innovations that are only possible through collaborations rather than competition. And the development of open source software, such as Wikipedia, are only made possible by this collective intelligence. And A-Life studies have found that diversity is crucial to maintaining an ecosystem. And it is important to maintain diversity and to be able to incorporate destabilizing factors into the group in a way that does not exclude them, but makes the most of them. And this diversity is the key to achieving evolutions by the collective. So to summarize, A-Life is a field that seeks to algorithmically create nature itself in order to understand life. And one way to achieve this is to create open-ended evolution. And we are trying to achieve this through emergent phenomena from 3 angles. So the embodiment, collective phenomena, by individual interactions, and the ecosystems. And as someone who studies communications and communities on the internet, I'm very sympathetic to A-Life's idea that incorporating all these characteristics of life will lead to more adaptive and sustainable production. So if you are interested in design or art using AI and other technologies, or if you became interested in AI life through this talk. So this is a book that you should probably read, so that it could also enlighten you to go beyond what's possible with the current AI. So that's the end of my talk. Thank you for listening.
Thank you, Mizuki. Yeah, amazing and fascinating field. And I really believe it can bring something else. We're talking a lot about creativity and AI today. Really happy about that. And our third and final speaker, before we start the discussion and answering questions, will be Antoine Pasquali. And you're still muted. Just making sure.
Yes, now you can hear me, right? Okay.
Yes.
Thank you very much for inviting me, Olaf, today. And thank you, Nathaniel, for organizing this European AI Week. This is a tremendous occasion to see you all. And so my name is Antoine Pasquali. I am CTO at Cross Compass and a research advisor at Cross Labs. So today I'm not going to talk much about Cross Compass, well, a little, but I want to talk about AI companies in general in Japan and see how Cross Compass is doing there. And I want to talk about the research and market trends in Japan especially, but I guess they are similar elsewhere. And I want to give a last word on where innovations come from, just for the fun of it. Right, so top companies in Japan. So now I'm very sorry, Mika, because Sony Ai was founded in 2020, and it's not on my list, but it should be at the top. So they are sorted by date, reverse order. And so NeuroPocket, they actually focus on fashion. At first, they work with Uniqlo, and then they diversified in smart city and so on. So what I want to say is that these are only companies that have AI consulting as the core business, right? This is very important. And most of them, well, they are all startups in this way. Ascent Robotics, mostly autonomous driving and robotics, Cogent, NLP solutions. LPixel is medical for diagnosis. Hackerus, yes, they use machine learning techniques for manufacturing, preferred networks, also autonomous vehicles, robotics and manufacturing. Aria, medical at first, and then edge computing and manufacturing. DeepMind, they focused on edge computing after Intel invested in. Abeja, mostly big data, IoT. And so actually Cross Compass is one of the oldest companies, 2011. And because of that, we are interested in many different fields. And the ones written in green are projects that we have on a regular basis. But the other ones, we might have had POCs and discussions with customers from time to time. So you see the first column, our main focus is smart factory and mostly manufacturing. So anything there we have done since 2011. And then we've done some smart technology, smart business, smart society. I will not discuss any of these projects today because we don't have the time, but I want to say that basically since 2015, we've had about 80 projects per year and growing. Of AI consulting. So just to give a word on Cross Compass, so funded in 2011, I joined in 2015, which is more or less when we started using deep learning. And we funded Cross Labs in 2019 with Olaf and Katsunobu Suzuki, our CEO. And you can see over here is Olaf. I'm over there. And our investors, you probably don't know Yaskawa, they do industrial robotics, but you know Epson, they also do robotics. CCS, they do industrial lighting. Softbank Investment, you might know Nisoko-san, they actually have a business in human resources for the industry. So we are very much industry oriented. One particularity of CrossCompass is the fact that we have about 60% of our employees that are from overseas, 18 nationalities, as you can see from the map on the right. And our corporate philosophy is AI closer to you. Right, I want to talk about the trends. So first, starting from the point of view of research, probably all of us would agree that we've had at least 3 booms in AI. And well, the first one on good old-fashioned AI in the 60s, and then expert systems, then machine learning is the most recent one. And then our feeling is that now we've entered the 3rd winter of AI already. Right, we are here, and we started a new boom, and that's the boom that Mizuki was introducing, which is the boom of artificial life. And we are predicting that this boom is going to be even bigger than the previous ones. So these research trends actually mean something. It means that during each boom, you are in an exploration phase, right? And then during the winters, you are in the exploitation phase. So right now we are in the exploitation of the boom 3 and in the exploration of the boom 4. And that's very important for business because some customers might be interested in the technology itself, that's exploitation, or in the research, and then that's exploration. Now, the market trends, well, the big picture first, of course, you know that we are currently in the transition between Industry 3.0 and Industry 4.0. And Olaf just introduced Industry 5.0. So 4.0 means everything is connected and we can maintain the equipment from afar. And basically, there is no need for humans anymore. But with 5.0, the idea is that you actually make robots or AI work together with humans. And so hopefully this is where we are tending to. This transformation is called digital transformation because everything gets digitalized. And so it's the same with society. Society is going to be from 4.0 to 5.0. And hopefully this is a digitalization for a better sustainability where people can spend less and have a better quality of life and so on and so forth. So that's the big picture. Now, if we look at it a little more into the technology, so this digital transformation is supported by 3 main technologies that we got from the beginning of this century. So big data is very important in machine learning because basically you need data to train your algorithms. And silicon chips and the miniaturization of silicon chips allows us to have smaller and smaller devices like your smartphone, and obviously internet. That was a big thing for humanity, you would say. And so the point is that each of these big technology get transformed into something new thanks to AI. The big data becomes some smart technology where you can make informed decisions based on statistical information. The silicon chips allow to do better and better embedded devices, smaller and so on. And the internet allows us to do Internet of Things. So to plug everything onto the internet and to create these smart objects that can do everything autonomously. Right, so now going even deeper, and this is what happens mostly at CrossCompass, but also other companies here in Japan. So what we've seen since 2015, which is more or less when the work started with our customers in AI, basically we had to train them on our basic technology first. So to teach them what was AI, because AI is a big word and people have many fears about it and they don't know anything. So the very first thing is to train your customers to understand basic technology, to have a proper discussion and so on. So a lot of effort has been done and it's still being done in AI basic technology to create algorithms, to simplify them, to make them more performant and so on. And then on top of that, progressively, we create tools for our customers to visualize the results with AI, to actually deploy them in embedded devices, to create solutions for their own products, and also to simulate data rather than collecting it, because collecting data is very expensive, and finally integration. And then the last trend, which is to the consumer, up to the consumer trend, is going to be a way for AI to finally reach the final products on the large scale. And for that, basically, well, we needed to sort out some IP issues, and I think more or less the trend now is that it's sorted out. We know what is intellectual property in AI and so on. And then now our customers, so partners now, they are interested in creating some environments where they can develop by themselves, deploy by themselves, and train by themselves these new technology. And when they incorporate that in their ways of their business, basically they can finally integrate fully AI in their final products. And this is how we can reach this industry 4.0 and society 5.0. Right. So I want to go quickly on this. And again, I could spend hours talking about our projects, but I just want to give one last word, and that will give you some idea of what I think about innovation at CrossCompass. So we all received this email from Nathanael, where there's some interesting text. He says, this message was not written by an AI, neither it is fake news. Okay, fine. And then there's this Alan Turing emulating René Magritte in a time machine. I have no idea where this comes from, and I hope he can put some light on this sentence later on. But okay, I was wondering what is this? Okay, what does it mean? So I look at the message, the invitation in LinkedIn for this conference, and then again I see Alan Turing emulating René Magritte in a time machine in his last message. Okay, I see, okay, why not? It's there. And then there's something more. This message was not written by an AI, but the music in this video was indeed. Okay, so now there is generation of content thanks to AI. So this gives me an idea, and probably you've heard about this article, and this was by Kevin, Lisa, and Olaf, very bright people, you know Olaf, but the others as well. And from our lab, Cross Labs, and they created this new algorithm that relies on the clip from OpenAI. This model basically can provide a description, a text description based on an image. But here they use it the other way around. Basically, you give the model clip draw a text, and it creates a drawing. And what's interesting here is that it creates a drawing with strokes, just like a painter. So I gave this strange sentence to the algorithm, and this is what it came with. And so if we look, basically, it looks like, yeah, in the middle, there's Alan Turing, probably. It looks like Alan Turing. And then at the top, maybe it's René Magritte at the top. But then there is this blue thing that I have no idea what this could be. So I pushed things a little further. And so you have to understand that this article came up quite early in a trend of new articles and research in text-to-drawing synthesis. And one of the most recent implementation, actually by Catherine, is the VQ-GAN clip. VQ-GAN is able to create, this time, a pixel-based representation of this text prompt. And so here again, we can see a representation of Alan Turing that the model created. I guess the style is kind of Magritte type. And then there's this thing in the middle. And I'm like, okay, it's there. So what is this? And so my feeling is that that's the way the AI decided to represent a time machine, right? So basically, if ever one of you guys wants to innovate and create a time machine at one point, well, here is an example of how an AI can help you in the design of your time machine, right? So to give you this take-home message, just follow your ideas and don't hesitate to combine different fields of knowledge. Innovation may come from where you least expect it. And that's my end of presentation here. Thank you very much.
Thank you so much, Antoine. Very nice, very nice, unexpected finish. Yeah, I think we really have a trend today. We all talked about creativity in AI, and perhaps we're feeling that this is a missing part. I've definitely heard that a couple of times at also the Sony CSL open house these couple of days. I think, yeah, also this was a big theme this year at the European AI Week. All right, so let's maybe we have a little bit of time left for discussion. Feel free, anyone in the audience also to post a question in the chat here. But yeah, what do you guys think about each other's point of views? And maybe would you like to add something about uniqueness and maybe challenges? As I feel we insisted more on those challenges for AI in Japan, things that we are yet to overcome, and perhaps we have different ways. To different ideas that in order to overcome that, maybe starting by Mika, would you like to start?
Thanks, Olaf. Yeah, when I was listening to you, especially of course about the robotics part, I was reminded of some of the reasons also why I came to Japan, specifically also joining Sony with the Aibo robot, which I think at the time had this radical idea that essentially robots can be used not just for manufacturing or tedious tasks, but they can or maybe even should be used for entertainment. And that was really, I mean, to me, that was at the time a pretty radical idea. And I think that this sort of still resonates in a lot of the work we do in Sony and Sony Ai. Specifically, for instance, if I think about our food project, where, of course, in the food robotics sector, for instance, many people are looking at kind of automating tedious tasks for people. And I think that's a worthwhile activity. But I also think there's this additional space of exploring what this technology can do in terms of creating new food and new experiences that might be outside of just kind of like automating burger flipping or something like that. And to me, that is in many ways one of the contributions that I think Japan made to this space in many ways. And I think that focus I think is kind of interesting. I do want to also then though say one thing, because I did at some point also research some of these things that we think about, how Japan thinks about robots, for instance. And it turns out there is actually some quantitative research on this, showing that in many ways, quantitatively, Japanese people are also afraid of the robot apocalypse, similar to what maybe people in Europe or elsewhere have. So I think the picture is actually quite complicated, but it's certainly interesting to look at, you know, cultural differences and where they might come from. So that's sort of one thing I might add here. I think as a society, Japan does face maybe not unique challenges, but challenges in a very specific way. You already mentioned many of those things. For instance, aging society, I think that's a key topic here that maybe we can, you know, address with technology. Yeah, so that's maybe sort of some of the first thoughts I would have. And of course, like to me, maybe to sum it up also, artificial life, I do think is a very interesting area. And I've also published paper in this area. Yeah, it's going to be very interesting to see whether what Antoine is saying is true, whether this is really the fourth wave, or what is the fourth wave? That's kind of the interesting question, I think.
Yeah, I saw that has been relayed to Twitter already. I think, yeah, definitely there is a playfulness, isn't there, in the AI in Japan, and perhaps, yeah, we are very playing with the idea of AI much more freely here. It's funny because there is this opposition of being. There's this paradox of having to automate very quickly if we don't want our economy here to collapse simply and purely. But as well, on the other hand, we are really into being still very creative in face of this big challenge. I really, yeah, I kind of appreciate that idea, because it's a bit like Ken Stanley usually puts it. what is it? Genius, I'd say, cannot be planned, right? Or excellence, you can't plan for solutions. You have to leave for some serendipity, and I think AI is going a lot towards that path. What do you think, Mizuki?
Yeah, thank you for a very interesting talk and questions. So I think the AI has focused on optimization and making things more automated, and life is more focused on exploration, like Antoine pointed out, and also generations. And that I think has very nice connections to what Japan is good at. So making toys, making new things, and so on. And I think we are Japan is a little bit behind in AI technology compared to the cutting edge countries in creating automated robots in industry or things like that. But like Olaf mentioned, but on the other hand, we are really good at making toy robots or creating mangas or something to do with entertainment. Also in the game industry, we also maybe still strong. And there, I think we have a still big chance because in this virtual world, there should be something should be created continuously. And so there, I think Astral Life technology should play a bigger role. And the focus on people are getting to notice that these open-ended algorithms could be very useful in these kind of fields. So I look forward to what would happen if more people are involved in making AI life technologies more advanced.
Mm-hmm. Not only more advanced, but in your book, it's really about being more lifelike, and I like that. Like sort of AI is defined like that, right? At least that's how I teach it to my students at Todai. I tell them, yeah, AI is imitating human intelligence, and it has been like this. It's not about general intelligence; it's actually about human intelligence, right? It's the only intelligence that we really know, and that what we were talking about. But then, lifelike is not human-like, right? It's more general than that, in a sense.
Yeah,
so,
exactly.
and I guess you're pushing that idea in your book.
Yeah, exactly. So there are so many different variations of life, and I think I like AI life because AI life technology is trying to get those intelligence, not just human intelligence, into technology, and that actually expands what's possible.
Mm-hmm. Yeah, that's definitely, yeah. For me, of course, it's close to my research heart. Yeah, what do you think, Antoine? Is that something that would be strongest here? We have an edge in Japan to accomplish. And yeah, what are besides what you already said? What are our challenges here?
Just to rebound on the last thing that
Sure.
you mentioned. So I feel like the last boom, so deep learning and so on, the AI was focusing on solving discrete problems. And basically, it's very good at watching an image and telling, okay, there's a car, there's a horse, it's very discrete. But artificial life and the next boom is going to focus on more continuous problems, how to adapt in real time to the situation, manage a body, or the way the way we humans use our body is the most and most difficult part to understand, and this is a struggle in Japan especially. So why this is important in Japan that we move forward, and why this is important that we do artificial life is exactly because of what we call the takumi. The takumi is basically the craftsmanship, right? So we know the population in Japan is aging, and all the experts who are able to do very precise craftsmanship on in the industry or for their art. They are aging and they are not being replaced. And for craftsmanship, you need your body to sense, for example, a surface, or to walk on a surface, and so on, and to build objects and to build pieces for your equipment and so on and so forth. And to do that is not just pure intelligence. It's not looking at pictures. It's not enough anymore. And so that's the struggle right now that Japan is facing, is that these people are aging and we need to replace them very quickly. And we don't have anyone else able to acquire this knowledge, because actually the young population, not only they are too few, but they are not really interested in this kind of jobs. And so here we have to find solutions very quickly in a domain where the actual technology that we get from deep learning is not efficient. So we have to look very quickly at turn our heads towards this new kind of AI technology that we can build, which is coming from artificial life. And then what's special about Japan is obviously the culture. So robotics, and even if there is some fear of AI, fear of the robots and so on, they are also used to having AIs and robots as pets, as toys. And in mangas and so on, often the robot is a friend. Doraemon, for example, is a robot, and it's a very cute character that children love and so on. And so they see technology as a friend. And I don't think many cultures share that feeling. So that, I think that's what makes Japan special, these two aspects, the aging population and the fact that they are very focused on quality and applying skills in an ancient way on one side, and the other, the culture.
Mm-hmm. Yeah, I guess the historical context, I guess, and the culture influences a lot the way I guess AI is being crafted here, and there is I think Japanese people relate strongly to AI as companions, right, as partners that have their own sort of spirit. And I don't know if I don't know, because after all, I just lived here for what is it, 10, 15 years. I wasn't born here. Maybe I'm mistaken, but that's how I feel as living here. Maybe it's something about a sort of drive towards trusting the agent, or offloading our own agency and trusting the machine, something more than something that would happen in the West. And I guess, there is research on this very concept of autonomy that would be, I think, the most promising to generate, I guess, more general AI, because AI is digging very deep into very precise craftsmanship domains, but it's not able to port over different areas. And I guess one area to fix or to start addressing that would be some sort of maybe Mika, your interest in mine in language. I guess a language for general deep learning, a way to transfer, I guess, optimization functions, something like that. I don't know what it will be like, but I think that's the key to next steps. What do you think?
What's the next step for deep learning, or what's the next step for language, or for Japan?
Oh, I guess it's for deep learning, but in particular in Japan, in that context. Yeah.
Well, I mean, I think I'm not. So I would be a bit careful with some of the things that I'm hearing here. So I do think it's very easy to make cultural statements, but they are also very often wrong. So I think the situation is quite complex. And certainly, it's very easy also to talk about like Western philosophy, maybe German idealism, and the relationship between people and nature and machines in Western European cultures as being sort of a history of a gap, for instance, people being disenfranchised from the technology that they develop, or thinking that the technology disenfranchises them from nature and so on. And I do think like lots of this stuff like easily resonates, but I also think we need to be careful with sort of stereotyping cultures in this way. And I also, since I'm talking now, I do want to address one point, which I do think that I think we have not yet reached the limits of today's technology. The things that maybe Antoine is saying in the exploitation phase, I don't necessarily see that actually. I think deep learning machine learning, I think, has still a lot of interesting potentials. And I think specifically actually showing the potential for controlling bodies, and especially in highly dynamic environments and so on. So I think maybe this is exploitation, I don't know, but I think there's still like new architectures, new things that can be developed. And I think the most fruitful right now, at least for me, is combinations of thinking about open-ended learning and the strong function approximators that we have with deep learning.
I agree. This is and it's very dangerous to go into stereotypes, but in order to simplify in pictures, my daughter just woke up. I guess we have to simplify while preserving this complexity and recognizing that. I guess this picture about what was very like this week. I think we had a lot from Gary Marcus saying exactly those things. Maybe you followed that on Twitter. There was the huge sort of a peaceful fight about those conceptions, that deep learning being dead or not. And I think so he says that we're hitting the wall, and I think Joscha Bach posted a picture that we're hitting the wall in the sense that a huge robot is hitting the wall from the top, and that's the way deep learning is doing. And definitely we're not done with that kind of progress. But it's never too early to I guess look at alternatives. So I like both ideas. I guess we're reaching the end of the session now. I'd like to discuss much more can be said, but we'll pause the discussion and continue it another time. Thank you all again for making time, and thanks to the audience and Nathanael as well for a lot of work, effort for this week. I think it's been very fruitful, lots of discussions, very interesting things. I hope we get more relations between Europe and Japan as well. I think things are on the way, and maybe next year we can announce nice news. All right, over to you, AI Week, and bye for now.